This problem is called squares of sorted array. We are given an integer array num sorted in a non-decreasing order. We have to return the array of squares of each number sorted in a non-decreasing order. So we are given as an input non-decreasing sorted array. So for example, in the example 1, we have -4, -1. So basically numbers are increasing, or at least if we have duplicates, they are non-decreasing. We basically have to convert this to the square. So each element has to be multiplied by itself. So for example, -4 when multiplied by -4 is equal to 16, and the 16 will be here. But then after sorting, of course, 16 will be second to last because it is larger than, for example, 9. And 9, we got 9 by multiplying 3 by 3. But because we have a negative number that's larger than the absolute value, we will have a square that's larger than the absolute value. Now, the length of the array is from 1 to 10 to the 4th. So we are looking for a linear time complexity solution. The elements in the array are from -10 to the 4 to 10 to the 4. And also, as we already know, the nums are sorted in a non-decreasing order. There's also this follow-up that says the squaring each element sorting the new array is very trivial. So basically, we could just go loop over the every single element inside of the array, multiply it by itself, and then basically sort the result. Insert each of the multiplication results in another array, and then sort that array, and basically just return it as the solution. In that case, because we have the sorting part, we would have n times log n time complexity. We want to try to find the solution, the linear time complexity solution. Now, we already said that basically if you are looking for the largest square that we will have, the best candidates that we have, let's just copy over this example that we have given in the problem statement. The best candidates that we have is basically the smallest negative number, because that number is the largest in the absolute value of all negative numbers. And then the next best candidate, or better candidate, depending on the absolute value of them, is the largest positive number. So basically, we are visiting the two extremes: the lowest possible number and the the lowest negative number and the highest positive number. And basically, those are the best candidates for the largest square. So we will basically kind of backtrack. We will be inserting the elements in the result array. Result basically representing the sorted squares, starting from the end. We already know that the length of the result will be basically the same as the length of the input array. Now we will have the 2 pointers, start and end, and then we will just check if the start, so -4 times -4 in this case is 16, and n 10 times 10 is 100. We will just check if the square is either larger at the element that start is pointing to or that end is pointing to. In this case, we know that it's 100 because 100 is larger than 16. So in our result, we will place 100 as the last element. And we will move our end pointer because we basically have already used this element. We have calculated its square and put it in the result. So we can move our end array. So end pointer. So in this case, now we have start -4, which is the score 16, and now we have 3 times 3, 9. So now start is actually the pointing to the element with the larger square. So we'll just copy over 16, and we will move our start here. So basically, you can notice the pattern. Whenever the start is pointing to an element that's larger, we will basically take the larger in terms of like having a larger square. We will take that element, copy it over to the result, and we will move our start. We'll just do start plus, we'll move it to the right. The opposite goes for the end. If end is pointing to the element that has a larger square, then we will basically decrement it and move it to the left. And we will perform this. So in this case, then we will have basically, we will have 9, because 3 is now, 3 times 3 is 9. And then here we have a square of 1. So we'll move our end. And then we will have 1, because now 1 is larger than 0. And then finally, basically start is now pointing to this element. And then finally, we'll basically have 0. And the next time, we'll basically decrement the end. And now end is pointing to an element, to an index smaller than what start is pointing to. So we know that we can break our loop because we have already the resultant numbers. So basically, this is a two pointers approach, and it will lead to a linear time complexity. And if we omit the space complexity needed for the result, we will basically have constant space complexity. First, we will declare our result, which will basically be the same length array as the input array, and then we will declare our start and end pointers. Start will be pointing at the first index and the first element, and the end will be pointing to the last element. We'll also have this I iterator, basically a writer that will help us to know to which position we are now writing elements to the result. Then we will basically have a while loop. It will move as long as start is smaller or equal to end. So as long as basically end is pointing to end that's equal or larger than start. Then we will basically calculate the square start, basically the element that the square of the element the start is pointing to, and the same will be applied to the element that the end is pointing to. And we will check if the square start is larger or equal than square end. In that case, we can just take the element that square start is pointing to, and we can move our start pointer to the right. Otherwise, we will have basically an element that that end is pointing to that's larger, that has a larger square than the element that start is pointing to. So we'll just copy that element to the current position of I, and we will move our end pointer to the left, so we will decrement it. Then we also, instead of incrementing the I, because we are basically inserting the elements backwards, we will just decrement it. And then finally, we'll just return the result after the while loop invariant is broken. So after start is larger than end.